Welcome to Study Loop.
This is the answer to Chapter 22, problem number 32 from the Smith Organic Chemistry textbook. And this problem is asking us to draw tautomers for each of three molecules. And so remember that a tautomer, or tautomer, however you care to pronounce it, is just the molecule is exactly the same. It's a constitutional isomer, and it's a constitutional isomer in which the double bond has been moved and a proton has been moved. So these were introduced in the ketone chapter. So ketones can always be drawn as a tautomer where there's a carbon-carbon double bond from the carbonyl carbon to the alpha carbon. And rather than the oxygen being double bonded to the carbonyl carbon, it's singly bound and it has a proton on it, so it's an alcohol. And remember from that previous chapter that the keto tautomer is always more stable than the enol tautomer, which is why those molecules tend to occur as the ketones. And so likewise, when we're talking about amide tautomers, the amide conformation, where the oxygen is double bound to the carbon and the nitrogen is singly bound to the carbon, is always the more stable conformer than the nitrogen being doubly bound and the oxygen only being singly bound and the oxygen being protonated. So in A, for example, so this is the molecule that we're given here on the left, and the tautomer would be this molecule here on the right. And the arrow scheme here shows that they do interconvert, but predominantly this molecule exists in the amide tautomer, which is why the bottom arrow of these two is much bigger, showing that preferentially this side is favored. So for B, it's the same thing. The amide version is highly favored over the tautomer. And again, for C, the amide version this time is the molecule on the right. And it, again, is highly preferred over its tautomer just because the energy conformation is lower in the amide molecule than it is in the tautomer of the amide. And since energy determines just about everything in chemistry, the lower energy molecule is going to predominate. And in all of these cases, it is the amide rather than its tautomer. And so that is the answer to chapter 22, problem number 32.